Now in this video I thought we would change things up, and we're not really going to do a circuit or anything. We're just going to look at the electrical property of capacitance. So this is an LCR meter. It measures inductance, capacitance, and resistance of components, and it does a really good job. So we're going to turn that on. So a capacitor, I have a little one here, but it's a couple conductive areas separated by insulation. And so you want the conductive area to be as big as possible, the insulation to be as narrow as possible. But in case, I'm going to put these close together in there, and the way that we have it, it's going to get kind of close to 1 picofarad. So pico is 1/1,000,000th of a farad. So we would have to do this. Now we're up to about 4 picofarad. But there we go, we actually made 5 picofarad. That's the best I've done with this right now. So to compare that, that was 5 picofarad, and this is a 10 nanofarad capacitor. And it's probably going to be off a little bit. That'll be more accurate. But so 10 nanofarad, that is about 2,000 times as much capacitance as what we got from the wires. So now, the reason why I'm zoomed back this far was so you could see me inserting stuff in there and see the display. So that was a bit awkward. I'm going to use much longer jumpers here, and then I can zoom in, because you already saw the basic demonstration. We're going to do pretty much the same thing. Now I also have, you can see capacitance going to go up because these are a lot longer right there. Goes up by really easy. Now I have the breadboard here. I removed the power because we're going to actually measure the capacitance of the breadboard there. So we're going to zoom in. You already saw where the wires were, and now you can see the display a lot better. So 0.7 picofarad. I'm going to put the blue jumper to the negative rail there, and the red jumper I'm going to plug back into the unit. But now we're going to put to the red row right there of the breadboard. So that's the power supply row. So there's a metal conductive area running down along the red side, and the blue side, they're spaced together with some plastic. So if they were closer, they'd have more capacitance and whatnot. But there you can see it's fairly high. Now I have jumpers going across to the other rail right there. So actually half of the capacitance that we're looking at, plus whatever the wires are making, if I don't accidentally pop out the wires down here, but half of the capacitance that we see there is also that side. We're getting half from each side. So if I pop one of these jumpers out, it'll go down in half approximately right there. And also we can look at the capacitance between 2 rows that are next to each other. So these go 5 across, and we can look at that. So if you have a circuit you put together that is extremely sensitive to capacitance, you know, maybe that'll be enough to affect it. But the vast majority of circuits, that makes really no difference at all. So that's the wires plus the rows there. If I separate the wires, we'll have a better idea of how much capacitance those rows are providing. So probably close to about 4 picofarad, something like that. But in any case, that's really about it. Just be aware that capacitance is all over the place. If you have a really sensitive circuit, it may be affected. But that's really rare. And when you learn about those circuits, you'll probably learn about whether stray capacitance will affect them. But hopefully you still found the video interesting. Make sure you check out one of the other videos I'm posting. Click like, subscribe, the bell, all that. Donate Patreon if you can. I have links down in the description. That will help out a ton. I will see ya in the next video.